So we're going to need to take the first derivative and set it equal to 0, find out if it's undefined anywhere. So the first derivative is going to be 2 times cosine, and now it's raised to just 1 as an exponent. Next, take the derivative of cosine, which is negative sine of x. And there's no place where this is undefined, so the next thing to do is find out where does it equal 0. And since it's already factored for us, then just set each factor equal to 0. So where does cosine equal 0? Where does negative sine, or in other words just sine, equal 0? So cosine would look like this, and it's going to equal 0 right here and right here. There's 2 pi, and the middle would be pi. This one is at pi over 2, and this one is at 3 pi over 2. And over here we have sine equal to 0. So that would look like this over the interval from 0 to 2 pi, as the directions say we should. So this would be pi, and this would be x equals 0. And then actually it does include the 2 pi. So include the 2 pi. There's all the critical values for the first derivative. And then let's see if we can make any sense out of this graph. So cosine of x squared on the interval from 0 to 2 pi. So if it's squared, it's not going to be negative. The biggest it would get is 1. And then take a look at the graph. Nice bouncy ball. And so we have things like pi over 2, trace, and at pi divided by 2, it's down here at a minimum. So we can pretty much split up the graph. This is 0 to 2 pi. So in the middle would be pi. That would be pi over 2. X equals 0. 3 pi over 2. 2 pi. All right. So we've got, let's do the maximum values first. So that's at 0, 1. Then in the middle, which would be pi, 1. And at the end would be at 2 pi and a height of 1. The relative minimums are going to be down here and down here. So this was pi over 2, 0. And then this is 3 pi over 2. And then where is it increasing? So that would be from here to here. So that's from pi over 2 to pi. And then from here to here, so that's 3 pi over 2 to 2 pi. And then decreasing at the beginning from 0 to pi over 2, and then from the middle to 3 pi over 2. All right, there's all the first derivative stuff. And now for the second derivative. Where is it concave up and concave down? Well, we could take the derivative of this and use the product rule, or if you just factor out this negative sign, notice that it's 2 sine times cosine. Or in other words, the first derivative is really equal to negative sine of 2x. Those old trig identities come in handy every once in a while. So now we don't have to use the product rule. We can just take the derivative of a sine. So the second derivative is going to be negative. The derivative of sine is cosine, and then the derivative of the 2x is a 2. Once again, there's no place where that's undefined. We just need to find out where does cosine equal 0. And then divide all of those by 2. So we actually already did that work over here, except instead of it being x equals, it's going to be 2x equals. So 2x equals pi over 2. 2x equals 3 pi over 2. But when I divide by 2, that's going to give me just 3 pi over 4. So that's not even to pi yet, and yet this said to go to 2 pi. So I need another place. So continue this out another cycle and get 2 more solutions. Well, these are odd numbers, and then it's pi over 2. So you can just do the next odd number, 5, and then pi over 2. A 7, and then pi over 2. And then for all of these, finally divide, so it's all going to be over 4. And 7 pi over 4. And then we need to determine where is this graph concave up and where is it concave down. So to me, it looks like from here to there, this is concave up. Let's check it out. So pi divided by 4, yep, and 3 pi divided by 4, yep. So that's concave up, likewise over here. So we have concave up, that was from pi over 4 to 3 pi over 4. And the next would be, so from here to here, so this would be 5 pi divided by 4 to 7 pi, whoops. Here it is, to 7 pi divided by 4. So from 5 pi divided by 4 to 7 pi divided by 4, and finally concave down. So that would be over here. So from 0 to, so at 0, this is one of the few places where we actually have to consider including 0. So at 0, it is concave down to pi over 4. We don't include because it's changing concavity there. It's the inflection point at pi over 4. And then in the middle, it's concave down. So that's from, let's see, this was pi over 4, so this is 3 pi over 4 and 5 pi over 4. And then this last part right here is also concave down. So that's from 7 pi over 4 to 2 pi, and do include it. And there's everything.